Let's have a look at dipole moments. This is Dr. B, and this gives you an idea of the polarity of a substance, right? It's a measure of the electronegative nature of one atom compared to another, really, right? I mean, fluorine is far more electronegative than hydrogen, therefore this is a highly polarized substance. It would have a very high dipole moment. It's measured in debye units. HF is 1.92. Oxygen is much more polar than hydrogen. This has a dipole moment of 1.87. Chlorine, not as much as fluorine, so it checks in at 1.08. In fact, oxygen's more electronegative than chlorine. That reflects that. But do watch out for symmetrical molecules. This one is not symmetrical. Oxygen's more electronegative than either of these two, so we've got a net dipole. The electrons are spending more of their time up there. Plus, look at those two lone pairs. If you are looking at it in detail, there could also be a resonance effect there, so you might see that. So both by the inductive and resonance effect, this thing is pretty seriously polar. But if it's a symmetrical molecule, there is no net dipole moment. And that's the case with carbon dioxide, right? 0. Try to do these three. I guess this one already showed up. Does this have a dipole moment? Tetrahedrons are absolutely symmetrical, so no. Water is bent, 1.85. Looks slightly different than that piece of data. Okay, and ammonia. Yeah, nitrogen's more electronegative than hydrogen. It's the net plus the lone pair, so I'd give it some sort of value, 1.47. That is a very brief introduction to dipole moments.